Hi there. My name is Brittany, and I am taking an evolution class at Pratt Institute, and part of my assignment is to make a video explaining a biological process, or an evolutionary process rather, that I found on a YouTube video, which I did, and I chose to discuss a YouTube video about horseshoe crabs and why their blood is so important. And I have learned that it's actually a huge effing help to us to have horseshoe crabs around, because without them we would have major problems with a bunch of really common medical procedures such as vaccines and in vitro drugs and like flu shots, like all these things that you think are just like whatever, are actually tested for pathogens and endotoxins through the use of horseshoe crab blood, which is like kind of amazing because horseshoe crabs have been around forever and we're all like, ah, well, they're like old and gross and no one cares about them. But they're actually like super important. And here's a picture of a horseshoe crab that's saying you're welcome because we owe them a lot. So basically, a horseshoe crab is an invertebrate and therefore it has no natural immune system. So it obviously needs another way of protecting itself because they live on the shoreline of the ocean, basically in a cesspool of bacteria and just disgusting grossness, and they're not like the smartest things ever, so they don't really like know to, run away or how to take care of themselves, so they had to develop a different way of protecting themselves. So what they have is innate immunity. Horseshoe crab blood is also copper-based instead of iron-based like ours, which is why it's blue. The video made a point of making that the most impressive factor of horseshoe crab blood, which is silliness. But yeah, whenever a horseshoe crab gets injured in any way where toxins can enter the body, like with a cut or something, the blood clots up, literally building a shield against the invading bacteria, which is pretty interesting. And that's because of this process called LOL, or LAL, which is Limulus amoebocyte lysate. Limulus being the genus name for horseshoe crabs and their extinct ancestors. Amoebocyte is the name of the amoeba-like cell that is in the blood, or the hemolymph, which is the fluid that is akin to blood in invertebrates, that actually causes the clotting. And lysis is the breaking down of cells through the membrane. So LAL is used to detect any pathogens or bacteria that would not show up in any kind of normal staining procedure for the biomedical community that's testing these things. And the blood will just clot right up, and there are proteins that will actually break down part of the bacteria. So it's like super, super useful. And it is the most effective known procedure for detecting these things. And it's relatively harmless to the poor horseshoe crabs who are sacrificing their blood for us. I believe I read that the mortality rate is only like 10%, and that they get released back into the wild, and they take like a third of their blood. It's also a huge business. It makes a ton of money harvesting these horseshoe crabs and their blood. And what other fun facts do we know about horseshoe crabs? Nothing. No, I'm just kidding.